Hi students, welcome to the video lectures of software engineering. Today we are going to talk about evolutionary process models. What are evolutionary process models? So these models are specially designed to accommodate a product that evolves over time. And if you see here, it's mentioned over here. Software is developed through repeated cycles, and we call these as iterations. And then this focuses on delivering evolving versions of software and allows continuous refinement based on the feedback. All these things are possible since we are going through these iterations. Okay, so how these iterations will help in achieving all this, we'll try to understand. And also we will also discuss about the types in evolutionary process model. One is spiral model, second one is prototyping model. So basically, evolutionary process models, these are very, kind of a flexible approach for our software development. And each iteration builds on the previous one and tries to add some new features or try to add some improvements based on the feedback what we get from the stakeholders. Fine. And for example, if you consider a project, like let us say you have built some video game application and you have just released the basic prototype first. Then after getting some feedback from the end customers or the stakeholders, yes, you try to keep on adding some features. Okay, let's say a better graphics initially for a video game application. So you got this feedback from your stakeholders. Okay, just you'll try to add this to the existing one. So for every iteration, you'll just receive some feedback, and based on this, you'll just try to add this improvement or new feature to the project. Right. So now, if you go deep, this is what we have to discuss some key characteristics of these evolutionary models. So first one will be the iterative development. Just now we discussed. Iterative development is nothing but where our software will be developed in repeated cycles, or you can call this as iteration, right? So for every iteration, what happens? So we just get some kind of new features or improvements which are added based on the feedback that we receive from the stakeholders. Example, we have discussed about a video game application project, which you have delivered to the customer, and the feedback what you have got is to improve some better graphics. Yes, obviously you can just have this as a feedback from the customer. And once you are done with this, probably in the next iteration you may also get another feedback that to increase the levels or to add some new levels into the game. So the list goes on. So this is what iteration based. So next key characteristic of this particular evolutionary process models are continuous refinement. What is continuous refinement? It is nothing but, as I told you, you are getting a feedback from the stakeholders or the users. So we're gathering these feedbacks for every iteration is nothing but small cycle, whatever that we are doing our project. So with the feedback that is gathered during each iteration, we use this to refine, and also to refine and we try to refine based on the feedback, and we enhance the system. Understood? So this is what is a kind of, and some ongoing process, which will ensure that the final product will meet all sort of requirements to satisfy the stakeholders or the end customer. Okay. So that is what continuous refinement speaks about. Continuous is the name. That is the reason why we are using. It's an ongoing process, which will ensure that your final product, whatever you are going to deliver, would meet the expectations of the stakeholders. So then another characteristic, the third one is flexibility to change. What is flexibility to change? So when we all know that we are following this increment base, that is iteration, or sometimes we can say this also increment based approach, right? So where we try to adapt more easily for all the requirements that are evolving or keep on changing. So the new ideas or feedbacks or challenges which can be addressed as they rise from the stakeholders, and keep us with the product to stay very relevant with whatever the requirement the stakeholders are asking for. So for example, we just can compare some online education software, the online education tool or software. We built some software for this. And when we compare this under our evolutionary process model, so for every iteration, let us say for iteration one. So after iteration one, we released our online education tool or software to the end users. So who will be the end users? It will be the students and teachers. So now, when I say this iteration one, students and teachers have started using that, and now students have reported few changes, which can be very helpful for them in understanding the things in this online education software, or which makes them user friendly. And teachers also will suggest couple of things based upon their usage of that particular portal. So once you're done with your iteration one and you received the feedback from both students and teachers. So once you receive this feedback, what you'll do, we will just try to improve whatever that has been asked for. Let us say some students asked for some user interfaces and some kind of interactive features in the portal, and teachers are asking for some other thing. Okay, so like they are asking for to monitor the students or something, a tab kind of thing. So these are all falls under our flexibility to change concept. So the key characteristics which makes evolutionary process models as unique are iterative development, continuous refinement, and flexibility to change. So when I say iterative development, so when each iteration builds, we get the improvements that are being added based on the feedback that we get. And continuous refinement is after every iteration we get the feedback, and we just we just try to refine the system, or we try to enhance the system. And this continuous refinement is a ongoing process which tries to assure us or ensure us that whatever the product that we are building will meet the expectations of the stakeholders. Even the requirement changes dynamically. Since we are going through this continuous refinement process, the evolving requirements from the customers would not be a problem, and we'll just try to keep on adding the new features to the product. Then it's flexibility to change. So when we develop or when we give the product through these iterations, so for a couple of iterations we just get the feedback from the end users. The example what we took right now is a online education portal or tool which we give to teachers and students, and they have come up with some kind of a feedback that is to improve the user interface or try to add some kind of features which make students to have uh, engaged with the portal, and the teachers would be asking for more monitoring the students kind of thing. And all these things will be incorporated into the product. And that is how special is evolutionary process model. So then we talk about some examples in evolutionary process models. So first one is spiral model, next is prototyping model, right? So what is spiral model? So you can see the diagram here. This is the diagram for spiral model. So it also have the phases, since we were discussing this from the last many classes. So communication, planning, modeling, construction, and deployment. Okay, so communication, planning, modeling, construction, and deployment. So all these phases will make your project to start. That is to start and end. So where we try to gather the requirements from the end customer, and we plan according to whatever the resources that we have, and also we schedule. And also the most important or unique thing that makes the spiral model special is it's a risk driven model. Okay, I mean it has a risk analysis part, which is very unique in spiral model. And then it's modeling, then construction, where we start on implementing or writing the code here. Then deployment is to deliver. So as you can see here, so communication, we try to communicate with the stakeholders and gather the requirements. In planning, we estimate, we schedule, and risk analysis is done. Modeling, we design here, and construction, we write the code and we test it. In deployment, we deliver the product, and we get the feedback from the customer or the stakeholder, right? So especially to talk about this spiral model. So this is introduced by Barry Boehm. The main idea of incremental development, the main idea of spiral model is to have this incremental development with major emphasis that is made on risk management. So you just have to remember this point whenever you get any question related to spiral model. So you have to remember that the spiral model has a lot of emphasis on this risk management. So when you see this, you can observe these cycles. Okay. So what are these? So these are some kind of repeated cycles. We can also call as spirals, where each cycle would be focusing on identifying the risks, refining the requirements, and building a part of the system. So if you consider an example of a banking application, so the first spiral may focus on like gathering the high level requirements and designing the core system, and the second spiral would refine the design and address specific security risks that are there in any banking applications. Risk can be like fraud detection or something like that. Okay, so and moving further, the phases or the spiral loops, what does these include? And of course, we know all these communication, planning, modeling, construction, deployment. We also just try to talk about these spirals where this try to identify the goals, constraints, and alternatives by the iteration. And these spirals also perform, the risk analysis for each alternative, and not only finding the performing the risk analysis, it tries to develop the strategies to eliminate or to at least to reduce the risks, and based on the risk analysis that is performed, develop the product prototype or increment. So in the same way, the next iteration goes on, and I mean your next spiral will go on. So that is spiral model. Okay, so spiral model, when we talk about spiral model, so just remember the spiral model is proposed by Barry Boehm, and basically this is a risk-driven process model. Okay, so just remember spiral model is a risk-driven model. Okay, this is what the thing which you have to remember. Understand? This is a risk-driven model. So risk-driven model in the sense it have a risk analysis feature in it, which is most important thing. Then we talk about prototyping. So in this model, what happens is, a prototype. What is prototype? Uh, Prototype. So prototype is nothing but a working model. A working model. Yeah, with working model with a limited functionality to say, okay, limited functionality. Okay, this is what is prototype. So in this prototyping model, this particular prototype is developed, okay, early, and we just release this prototype to gather the user feedback, and based on the feedback, the prototype is then refined and a new version is built. Clear. So the phases include communication, a quick plan, modeling, quick design, construction of prototype, deployment, delivery, and feedback. So this is all about prototyping model. Understood? So we try to build a prototype that is a working model with limited functionalities developed, and we try to gather some early feedback since we deliver this prototype. Based on this feedback, we try to refine to get the new version of the product. Clear? So then what is the importance of prototyping model? So basically, so when you feel this prototype, when we say this for prototype, this will serve as a kind of the first system. This will serve as a kind of first system. What is this first system? Like where users get a feel, okay, of the actual system, and developers also get to build something immediately. Right. So this is kind of a stamen. When we talk about prototyping model, this can be used as some kind of standalone process model, and basically the prototyping model is used when the customer defines a set of objectives but does not identify detailed input or processing output requirements. And also the developers are unsure of efficiency of algorithm, adaptability of OS, that is operating system, etc. Right? So where we need a phased model, which is where the phased model is inappropriate. Yes. So hope you understood, students. Thank you.